Let's jump right into this incredible explainer. Today, we're tracking how an artificial intelligence evolved from playing pixelated 1990s video games all the way to uncovering the very building blocks of biology. It's the fascinating story of DeepMind and how their singular focus on understanding human intelligence led to a system that's literally solving some of the world's most intractable scientific problems.
Real quick, here's our roadmap for the explainer today. We'll cover 1. The quest for AGI, 2. Mastering the game board, 3. Beyond human knowledge, 4. The protein folding problem, 5. Winning the CASP competitions, and finally, 6. The ethics of AGI.
All right, let's kick things off with Section 1, the quest for AGI. So our story really begins with a staggering, almost impossible mission, building the world's first general learning machine. Now, the absolutely crucial point here is that artificial general intelligence, or AGI, isn't just about doing one specific thing really fast. You know, older systems like the chess-playing supercomputer Deep Blue, they were brilliant, for sure, but they totally lacked what we call cognitive breadth. AGI is all about mirroring the incredible, messy flexibility of the human brain. It's about creating an agent that you can drop into a completely novel problem, and it can just adapt and figure it out, exactly like we humans do.
Moving right along to Section 2, Mastering the Game Board. Well, to build a digital brain from scratch, scientists realized they needed a training ground. And it turns out simulated video games were the absolutely perfect environment for childlike AI agents to learn. Using something called the DQN algorithm, an AI agent was essentially dropped into classic Atari games like Pong. The crazy part? It wasn't programmed with the rules at all. It only knew 3 basic things: observe the raw pixels on the screen, take a random action, and try to maximize the score. And this brilliantly illustrates a concept called end-to-end learning. Left entirely to its own devices, the AI just figured out the controls from scratch. When they tested it on the game Breakout, after just a few hundred games, it didn't just learn to play, it discovered a completely optimal superhuman strategy. It literally figured out how to dig a tunnel around the side of the wall to trap the ball at the top, just racking up points. It learned this entirely on its own. How wild is that?
That brings us to Section 3, Beyond Human Knowledge.
Having totally conquered Atari, the stakes had to be raised. Enter Go, an ancient board game with more possible board configurations than there are atoms in the universe. Now, the first version, AlphaGo, made history by defeating the human world champion, but it was initially trained using 100,000 human games. The real paradigm shift, the actual game changer, came with AlphaZero. By completely removing human data from the loop, the AI acted as its own teacher. Starting from purely random play, it reached superhuman chess abilities by dinner time. Moving entirely beyond human knowledge was the absolute key to preparing the AI to solve problems that we humans just couldn't crack ourselves.
But here's the catch. Board games are neat, but they have perfect information. You can see the whole board. The real world, though, it's incredibly messy. So to prepare the AI for the absolute chaos of real science, researchers used the video game StarCraft. Here, the AI had to navigate continuous, real-time actions and deal with hidden opponent moves. It perfectly simulated the unpredictable, fluid nature of biological systems, and incredibly, it ended up beating top professional human players at that too.
Which leads us perfectly into Section 4, the protein folding problem.
You see, the video games were really only ever meant to be a proving ground. The ultimate boss fight was tackling intractable, real-world science. Which brings us to biology's absolute greatest puzzle. Since the 1960s, thousands of brilliant minds had completely failed to crack the protein folding problem. Basically, proteins are made of these 1D strings of amino acids that naturally fold into highly complex 3D shapes. Knowing that final 3D shape is the key to understanding exactly what a protein does. But computing how it folds, that was thought to be practically impossible. But the DeepMind team? They believed AI was finally ready to take it on.
And this matters immensely. Understanding proteins basically means understanding the literal machines of life. If we can accurately predict how a protein folds, we don't just speed up critical drug discovery for devastating things like Alzheimer's, dementia, or malaria. We open the door to long-term biological engineering. We're talking about creating new enzymes to break down environmental plastics, or even solving global agricultural crises. It's essentially a master key for humanity. So let's look at Section 5, Winning the CASP competitions.
To rigorously test their new AI system, which they called AlphaFold, the team entered CASP. Think of CASP as basically the global Olympic Games of protein folding. In 2018, they won, but they faced a really humbling reality. Their predictions just weren't accurate enough for real-world biologists to actually use. So they formed a strike team and completely evolved their architecture. Unlike the early gaming AI that only looked at pixels, they completely rewrote AlphaFold's data pipelines to deeply incorporate biological physics and spatial graphs. And the payoff? By 2020, they achieved such remarkable accuracy that they effectively solved a 50-year-old grand challenge in biology.
Now, what they did next is amazing. Instead of locking this incredibly powerful tool behind some massive corporate paywall, DeepMind ran every single known protein in existence through AlphaFold. 200 million structures, and they openly released all of them to the public. It was a massive, unprecedented gift to humanity that instantly accelerated chemistry and biological research across the entire globe.
Finally, we arrive at Section 6, the ethics of AGI. Because, let's be real, with this kind of godlike power comes a massive, heavy shadow of moral responsibility. As these AI models scale ever closer toward true general intelligence, the stakes become literally existential. As one of the sources poignantly warns, you can't look at gunpowder and only make a firecracker. Technology is inherently dual use. The exact same AI frameworks that can beautifully fold proteins and cure diseases can equally be militarized for autonomous weaponry and mass psychological manipulation.
In fact, the sources draw a direct, pretty sobering parallel between unleashing AGI and Robert Oppenheimer's atomic bomb. During the Manhattan Project, scientists understandably got caught up in the pure thrill of the science, delaying the deep moral consideration until after the bomb was already dropped. DeepMind's philosophy strongly argues that we simply cannot afford the classic Silicon Valley mantra of move fast and break things here. We have to thoroughly understand these systems in strictly controlled conditions before unleashing them. We have to get the ethics right the very first time.
So, as we approach a future that's going to be completely reinvented by artificial general intelligence, a really critical urgent question remains. How on earth do we govern a technology that could outsmart global financial markets and outinvent human researchers? How do we keep power over something that's infinitely more powerful than us? The thinking game has evolved from pixelated screens to the very fabric of our reality. And honestly, it's up to all of us to decide how the final move is played. Thanks for joining me on this explainer.